recording and we continue from here. So first of all, we will need to talk a little bit about the concept of the router. So if you remember, router is the most intelligent network device we have so far. Is the gateway to the internet and is the reason why we connect to networks or more. A router have three tables: a routing table, neighbor table, and topology. With all these three tables, we'll be able to send the shortest path message from location A to location B. Let's see in here, no? Okay. How many days they send me? In 3 days. Okay. So we say no and we click on this one. Alright, so we have a router. The router is the main reason why you connect network A to network B. Those two networks can be separately in different geographical space. It doesn't matter. The router will try all the time to find the fastest way to reach that network. Normally, router being very expensive, they don't have too many ports comparing to a switch. A switch have way too many devices, way too many ports, and it has absolutely no problem if you add additional. However, if you pay attention, do you see router have only two what? Do you see router has only two interfaces? Can you see these guys? Watch in here. If you look at the switch, look how many ports a switch have. Do you see? So switch in most of the term is called a dumb device because switch cause a lot of issue for us, a lot. And you probably learn in the 3rd or 4th semester about this. So a switch being a dumb device will cause a lot of problem, such as layer 2 loops, duplicate frames, broadcasting, storm. So it have a lot of problem. Now, as I said, the router having less interfaces, you need to be very wise how do you assign those devices. Also, look in here. You want to buy a router 4330, router, a Cisco router 4331. So do you see a single router is 4,700 Canadian US dollar. That's around 8,000 Canadian dollar for one. So these devices are very expensive. So you need to be very wise when you design your network. However, a router is the reason you can connect two separate networks. You can have a switch which you call it network 1 and you can have another switch here connected and call it network 2. So let's make it as a simple example. We have two switches. Question: what type of cable do I need between a router and a switch? No? What type cable do we need between a router and a switch? Come on, your assignment is about routing and cabling. It's about cables. Anyone? No? Anyone? So, Simranjit, is what? Is crossover, console, straight through.
Copper straight.
That's correct. It's a straight through cable. The reason why we have this one, if you remember, straight through cable, okay, straight through, or okay, straight through, whatever, straight through is a cable used between separate device, crossover between same devices. So in here we can have two straight through. The representation on the diagram is with a single line, while copper crossover is with dots, dots, dots. So we go to gigabyte 001 and we connect to gigabyte 01. We go to gigabyte 001 to gigabyte 01. So as you can see, we have two network, router 1, switch 1, switch 2. So you see, we have two different networks in here. However, router being a smart device, do you see the red mean the interface is shut down? Look at the simple comparison. Let's go in here, let's go to cable, and let's look in here. Fast forward. Do you see any difference between this one and this one?
LEDs showing different lights.
Yes, so green mean is running, red mean is down, right? But do you see, I was trying to say, you see, when you plug in something in the router, it's disabled by default. If you plug something into a switch, it runs by default. So that's why, because the switch is a dumb device. So let's make some simple network. Network A and network B. Let's add some computers. Ek, doi, tin, punch, what was it? Punch, sat, whatever. 1, 2, 3, 4, ek, doi, tin, char, punch.
1 2 3 4 5
Acha, okay, thank you.
this way.
Thank you. Right, so we have two separate network. If you want to represent it with a different color, you have a favorite color, let me know. Okay, this is network A, and this is whatever network B. Network A and is 192.168.1.0/24. This is network B, 192.168.10.0/24. So, is anyone having any questions so far? Is something not clear? Can you see? Is enough? Is it proper? No? Do you see the network? Is any question you want to ask me? Is clear enough up so far?
No, sir.
Okay. So let's connect the cables as well. So let's go here, connect through the copper straight, fast Ethernet 0 to fast Ethernet 01, fast Ethernet 2 to this guy, this guy. Okay, let's go here, fast Ethernet 0 to fast Ethernet wherever, fast Ethernet 03 to fast Ethernet 0, fast Ethernet 4 to fast Ethernet 0. So far, so good. Okay, so now, normally the packet tracer is a very interesting software. It will, if in real life it takes 50 seconds to enable the port, it will take 50 seconds until it will enable the port. Or you can click this button and will skip 1 minute. So if you see, click fast forward, it will move faster. Now, let's assign some IP address to these devices. 192.168.1.5. The gateway is 1.1. So this is 5. So let's put it in here. Dot 5. This is dot 10. This is dot 15. This is dot 20. And this is dot 25. So let's say this is the IP address we have in our network. I put it in here so you can understand, because for me, I know how network works. I'm trying to make it as clear as possible for you guys to understand it. We go to the second one, 192.168.1.10. The gateway is 192.168.1.1. We go to the third computer, 192.168.1.15, 192.168.1.1. To the 21, 192.168.1.20, 192.168.1.1. So if you notice, the gateway, every one gateway is .1, 1.25 and 192.168.1.1. Does anyone know why every one of these computer gateway is .1? Who is 1.1?
Which one?
Well, switch being a dumb device operating at the second layer, switch use MAC address. So the interface of the router is the gateway. So that is the reason why you go on the internet. We call it gateway for us. It's a gateway, you can go internet. But the computer goes through the gateway, which is the router interface, and goes online. So if you go in here, now let's start with the configuration. Say N for no and enter. You see, in a real life configuration, the router will look exactly like this, the interface, like this. There is no graphics. There is no graphics. The first thing that I would like to type is called enable. I will type configure terminal, and now I'm in the router memory. I would like to change the name from router to R1. Host name R1. Do you see? I change it from router to this one. I can put password. I can put whatever I want. Let me go here, preferences, always show port label. Okay. So you see, it will show me all the interface of everyone. So I can go to the interface gigabyte 000, interface gigabyte. So interface gigabyte 0.0.0, IP address 192.168.1.1, 255.255.255.0. No shutdown. We don't shut down the interface. And as you can see, the color changed. Do you see any difference? Color wise? Any difference between this and this? Yes. All right. So let's look to the clients. For example, I would like to ping 192.168.1.25. So let's go to simulator and let's type play. Come on. So you see, the client 1 want to send a message to client PC5. Do you see? It goes straight to this client. Now, let's configure this network as well, this one too. Exit, interface gigabyte 0.0.1, interface gigabyte 0.0.1, and 192.168.10.1/24. Good morning, team. Just a reminder of whatever. All right. IP address 192.168.10.1, 255.255.0, no shutdown. And now let's assign IP address to this machine too. Let's make it same. Let's make it 100.125.150.175, and here .200. So let's assign the IP address. 192.168.1.100. The gateway is 192.168.10.1. Oh, sorry, 10. 10, and this is 10.1. Yes, Ujjwal. Hello. Yes, what's up?
Hello, sir. I want to ask how we assign the IP address on what basis?
How do you assign IP address on what?
The IP address you were writing there. How did you how did you find that? And how we are, you were recognizing?
Would you please rephrase again the question so I can understand it a bit?
Sir, how do you get that IP address?
Okay. So normally IP version 4, if you remember from one of the class, has three classes, has 32 bits and three classes. Class A, class B, B and C classes. Class A start at 1 until 127. Class B start at 128 to 191. Class C starts at 192 until 224. These are the range. However, we have three types of IP address. We have private IP. Private IP address are IP which cannot go online, are for internal usage. Every organization have their public IP address and their private address to configure networks. Our home have a private IP and a public. Watch in here. If I go IP config, my IP is 192.168.0.186, but this is my private IP address. And I have my public IP, which is this. This is how I go on internet with this guy. Now, private IP address, private IP, okay, class A private. Let's say class A private. Right, class A private. Class A private start at 10 until 10.255.255.255. Class B private start at 172.16.00 until 172.16.255. Sorry, 31.255.255. And Class C private, it starts at 192.168.00 to 192.168.255.255. So now, what's the question?
Sir, can you teach us the way how to create a random IP address?
You cannot create random IP address.
Just for the assignment.
Man, you cannot create private IP. You can only use Class A private, Class B private, Class C. If you want to use Class C, there is no problem. This already, but you cannot build your own IP address. If you pay attention, in my network, what IP is this one? What class? What subnet? And is private or public?
Sir, it's class C.
Okay. Private or public?
Public. Sir, it's private. Private, yeah.
All right, so you see, no, this is private. This is a private IP address because it starts from 192.168 anyone all the way to 255. Can be 192.168 1.1, 192.168 10.200, 192.168 15.255, 192.168 50.50. All of these are private. So every organization make their own network. It's up to you as a technician to create your own network. Up to you. For example, if we use, remember, class A IP address has /8, which means 255.0.0.0. Well, what does it mean that? It means this. It's up to you to understand your own network. Yes, Kritika, what's up?
I want to ask how we come to know about network IP address we have to assign.
Nobody assigned, technician assigned them.
Okay, sir.
So you will work for an organization. When they build the organization, the team decide what class they are using based on the network. For example, let's say, what business do we have? We are a truck company, or yeah, so we have how many employee in the building? How many employee? 50. Okay. What class of IP address do I need to not waste IP address? Well, I will use class C because it has 24 bits and I have 2 to the power 8, which is 256, minus 2, which will result in 254 possible computers, IP, network devices, whatever. Now, if you have, okay, our organization is like Google. It has in each location 10,000 people. Well, in that case, I cannot use class C because I don't have enough IP address. So in this case scenario, I might use class B because I have /16 and to the power 16, because remember, IP version 4 have 32 bits. And in this case, 16 are used and 16 are off. And to the power 16 will result in 65,535 IP address. If you talk about an organization like Microsoft, Apple, or whatever, you then, Samsung, you use /8, which is class A, which in this case you have 2 to the power 24, which you have 16 million devices. Again, what you need to understand is that those are internal devices. These are only for local usage, not for outside usage, only for internal. Only internal. Yes, Harman Prita, what's up, man?
Sir, why we minus 2 when we are finding number of hosts in the IP address?
Because I think we talked about this one last class. Uh, the network ID and the broadcast IP are two IP address which cannot be used. Example, let's say we have a network called /27. What means /27?
27 bits are occupied.
Okay, so we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. The first 8 are on, 255. The next 8 are on, 255. The next three are the next quadrant is on, 255. Remember, we have these guys in here. So we have here ek, doi, chat, how is it? Punch, sat, at, batti, whatever, I forget, and hexotai. 1, 2, 4, 8, 16, 32, 64, 128. You need to multiply those guys. 128 plus 64, 192. So 128 plus 64 equal 192 plus 32 equal 224. So my new subnet mask is 255, 255, 255, 224. Now, I understand two things from this network. First, the number of 0 will tell me how many computers I can have in the network. How many computers? In this case, I can have 2 to the power 5, which is going to be 32 minus 2, which will result in 30 hosts per subnet. Again, why this one? Well, you see right now. The number of 1 tells you the number of subnet. To the power 3, 8 subnet. That being said, I can have 8 networks at 30 IP address. If you look at 8 multiplied by 32, you see it's 256. Taking from the right to the left, we stop at the first bit on, which is 32. Or the number of 0 to the power 5 is going to be 32. So we know that 32 is the addition number. 0 plus 32, 32, plus 32, 64, plus 32, 96, plus 32, 128, plus 32, 160, plus 32, 192, plus 32, 224, plus 32, 256. So we have 1, 2, 3, 4, 5, 6, 7, 8 subnets. So this one is a reference number. You know we cannot use that IP address. You know that. All right, so let's go in here. This is called network ID, net ID. It identifies resources on the network. It has no real value. Then we have the first IP address, first. Then we have last. And then we have BC. This is not the word, your favorite word. This is broadcast. All right. So the first usable IP address is 1. The broadcast is the next net ID minus 1, which is 31. The broadcast minus 1 is 30. Question: how many IP addresses from 1 to 30? How many IP there are? Go. Anyone? How many IP are between 1 to 30? How many IP?
29. So 30.
30, right? So these are 30, right? Okay, 33. Broadcast minus 1 is 63. Minus 1 is 62. How much is between 33 to 62? Still 30. So, you see, now, one IP is lost here and one IP is lost here. That's why we have the formula 2 to the number minus 2, or if you don't like n, 2 to the number of host minus 2. The minus 2, it means net ID and broadcast, sorry. No, broadcast. I'm sorry, yeah. So that's why we are using those two, network ID, and that's why. Do you see why we use now? Do you see why we have minus 2 now? So every representation, your network is /26. That means 2 are on and rest are 0. Which in this case we have 6. 2 to the power 6 is going to be 64 minus 2, network ID and broadcast, okay, which is equal 62 host per subnet. Do you guys understand? No. No, Has. No. Because we talk about subnetting. Okay, let's talk about routing, and then we will come back to subnetting, because it looks like you quite did not get the subnetting. We will spend few extra lecture into this, into the subnetting. It's okay. We have enough time, plenty of time. All right. So this is just the routing. We will come back to network soon. I want to show you something else. So we assign IP address. Now, question. Who provide the class C? Is the question you ask me. Now it's time for you to answer this question. Who will provide this IP network? Huh? What? Yes, the IT guy in the company are the one who decide. The first things they will say, okay, we design a new network. How many employee on the floor? How many floors? So basically it's the same question. How many subnets? Floors? How many host, which is IP address? Do you understand? This is exactly the same. So this guy will say, we need, I don't know, they are split in 5 floors and each one they have 30 computers. Okay, we have slash 27. Oh, we need more. Okay, then slash 19 slash 17, etc. So this is exactly how they work. Based on that, they say, you know what, we will use class A or B or C based on the scenario. That's it. So that's what, based on the scenario. All right, so we assign IP address to all of this machine. 192.168, 10.175, 10.1, 192.168, 10.150, 10.1. The network is here. Let's go in here. And 192.168, 10 dot whatever, 200, 192.168, 10.1. All right, so we finished this problem. Now, watch and learn here. Ping 192.168.10.100. The first request is always coming negative, is always request timeout, because it takes too much time until it reaches the host. Watch in here. PC1 wanna send a message to PC6. This is separate network. It goes to the switch and then goes to the router. The router go to the other network and then goes to whatever computer. And if the computer is on the network, nice. Computer is on the network, it will come back to confirm to PC1 that that computer is active. All right, so did you guys see what happened? Do you see that?
Yes, sir.
All right, now I have a question for you. But now, if I want to ping PC5, why it doesn't go to the router? You see, they discard it, block it, block it, block it. Why it goes only to the switch?
Because it's in private network.
Yes, they are in the same local network. They are all in network 1.0. That's why. Yes, you are right. You are totally right. So in this case scenario, computer make a process called ARP. Computer make a let me come in a minute. I'm coming in 1 minute. Just give me 1 minute. Yeah.
Hello, Manpreet. कितने हैं? Okay, क्या मीडिया वीडियो में है?
Yeah. Oh, what happened? So, what's a new song that you try to listen? Some this release. Who is this?
Manpreet पकड़ा मैंने.
So, what was that? Ab Dylan, Musewala, Karan, Pamrit, Babu. Who is? Oh, Arijit.
No. Urgent. Urgent. Urgent.
Ah, okay. Arjan Dillon. All right, so muted. Bande karde. All right, so let's look at here the problem. ARP stands for Address Resolution Protocol. Address is a protocol which operate at the second layer of the OSI and make end operation. From physics, have you ever heard of, you saw this symbol?
Sir, AND gate.
Yes, yes. So what is this AND gate? Because this is, from physics.
Switches.
Come again, Rajveer?
Sir, AND and OR gate are used in switches.
Yes.
Planning switches.
So the end operation, they look at the binary form of things. They are coming from electricity or from physics. What? What? Ujjwal. Nice. Let's mute his mic. All right, so let's say in electricity, if you go to the switch and turn off the lights, is off. You turn on the light, is on. On, off, on, off, on, off, on, off. Similar in computers too. You see, when PC1 want to send a message to PC5, they know they are in the same local network. They will make the process of AND gate or AND operation. AND operation will be like this. 1 with 1 equal 1, 1 with 0 equals 0, 0 with 1 equal 0. So AND operation is if both ends are 1, then result is 1. Now, any other combination is 0. So, the computer make AND operation between their subnet, okay, the network. So, let's say this is ping 192.168.1.5. This is PC1 IP address. This is the IP address of PC1 1.5. And then they look at PC5, which is 25. As you can see, this part is the same, right? Do you guys see? This part is the same.
Yes, sir.
As a result, they are in the same network. Now, if PC1 want to send a message to PC6, which is in the other network, in here, we know PC1 has an IP address of 1.5 and PC6 has a network of 10.100. Oh, 10.100. And in here, they figure out there is a problem. They will say, oh, wait a second, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 8 plus 2 equal 1. Okay? As a result, here they know that the statement is 0 and is false. As a result, they know the end operation, they are not in the same local network. So what happens is when the client detects that the IP is in a different network, it will automatically send it to the router because the router is the gateway. The router is the one who can switch from network A to network B. So yeah, so any one of you have any question about this one or something? Say it again. Huh? Anyone? Jashan, Simran, Harpreet, Nav, Karan? I like the last time, Simran, your last name was Singh. So I was like, what's going on in there? If I remember, I ask everyone in the class. So, any one of you guys have any questions so far about what just happened today? So let me pose to you another assignment. Today is assignment number 2. Right? And this one is very good and will help you out. Watch what's happening in the assignment. Let me show you. The difference between the first assignment and the second is here, and it's very important. This is very important. Let's download. So you download the packet tracer file. It's not the first time. We can save this one, basic router scenario. Let me upload it into the class until I don't forget about this one. Come on. Oh my God. Google, you are drunk. Okay. Packet tracer file for study. So, what you can try to do, if you ever have any packet tracer file, oh my God, is open the older version. No. Let me open the newer version. Let's see, open, we go in here, basic router scenario. What you can try to do is, you can try to go to the router, you click on the command line, here you type enter, enable, show running config, okay, show running config, and hit enter. And you just hit the space key, space, space, space. And if you scroll up, they will tell you every single command which have been input into this machine. The command was hostname R1, interface gigabyte 00, this is the IP, this is the subnet, this is 001, and this is the network. That's it, you see? So you can test this one. Now, every one of these, they have some interesting scenario. Let's go to your assignment, which is basic configuration. It's supposed to be here. Okay. Basic configuration of the switch. The file, this is the file. So you see, in here, you have a simple configuration of a switch. They tell you actually what you need to do. They tell you. So for example, configure S1 with the host name. Host name will be easy to identify the computer on the network. You click on S1, configure terminal, enable config terminal, hostname S1. And as you can see, you get 1 mark. Use Cisco for the console password. Lion console 0, okay, password Cisco login. As a result, I get 5 points. So what is this Lion console 0? Lion console 0 is a password for the console cable, which means every time you try to log in into the system, boom, you need to put the password before you will be able to continue forward. So Cisco, you type the password and that's it. Enable config terminal, password, enable password class. Okay, so we put that one in there as well. Or sometimes they will tell you to encrypt it or create a class or secret, etc. If you check result, you can go to assessment items, you will see it in there. So you see, in this case, I put the wrong command. So I can remove that command by just typing no enable password. No enable password. Yeah. Enable secret class. We enable the secret which is called class. Somewhere in here, where is it? Somewhere in here, I post to you all the commands. Enable configuration, enable password, enable secret, encrypt all the password. For example, if you just go here and type show running config, you see we see two passwords. For the console is Cisco, which is visible to everyone, and the secret, which is encrypted. Now, I want to encrypt all of them. Enable config terminal, service password encryption, and we encrypt all the password. Show running config. If you see, even the console password is encrypted. Enable config terminal. Use appropriate banner to warn unauthorized access. Okay, banner, message of the day, authorize, whatever. Authorize access only. Banner, message of the day. No, it doesn't want to paste that. Okay, so you put a new banner. Now, if the banner doesn't work, you can try to use a hashtag, but it works. All right. So what happened is, when somebody tried to connect, you see, authorized access only, violator will be prosecuted to the full extent of the law. So is the password again is Cisco. Now if I type enable, they ask us another password, which is class. Then I can type configure terminal to defend this device. All right, so you need to do the same step for the second router, for the second switch as well. I need to put some IP address. All right, switch 1, interface VLAN 1, IP address, and you have it in here. 192.168, 1.253, 255, 255, 2550, no shutdown. I go to my host, PC1, desktop. PC1 IP address is 192.168.1.1, okay? And I finished half of your assignment already. Oh yeah, and I need to copy the settings to ensure the settings will not be destroyed at the next restart. To keep the files saved, to save the configuration, you need to type copy the actual running configuration into startup, which means every time the router or switch restart, the network files are still there. Hit enter, and I finish half of your assignment. Banner, login, password, secret, hostname, IP, everything. So you can do this one as well to get used to the network configuration, network style, etc. Now, do you see something here? You see, you can try to answer some of those questions, okay? You have same network, they should be able to ping each other. So you have some question in here. Can click PC1, then click this ping IP address for the PC2. So you have to go to PC, command prompt, and ping the computer number 2 IP address. If it's successfully, it means you did it proper. So that's all about this packet tracer file. Is basic? No. This is basic configuration. So this is assignment 2. So any one of you have any question what happened in there? Any one of you?
Sir, we can use any password.
No. For this exercise, you need to use the password they gave you. That's how you get points. So you see, let's hit this one. Keep it on the left. This one requirement on the right. So you see, they tell you for the console, you need to use Cisco. So enable config terminal, lion console 0, password Cisco. Oh, no password. Okay, password Cisco, login. Okay, so we use this one. And to encrypt everything when you type enable is secret. Enable secret, and the secret is called class. Okay, and if you click in here, you see password, login, and this one. So yeah. Anyone? Any question for me?
No, sir.
No. Why you sound like no, sir? What happened? Why are you so upset?